Hello, can you hear me now? Is that better? Maybe? Oh no. Can't hear again. Okay. So oh, you can hear me now? Okay, there's this delay again. I tried to turn off the lag. I'm really sorry. I'm a bit of a grandma when it comes to all of this software, so bear with me. I thought this would be like the first time we would start with sound, but you're all saying you can hear me, so hopefully that's good. I can see some familiar names here from last week, so nice to see you again. And I see some new names as well. Okay, great. So you can all hear me, finally. Okay, good. We're off to a good start then this week already. So, what we're going to be doing today are upper and lower bounds. So, how do you all feel about this as a topic? Is it something that when you hear it, you feel really confident about working out upper and lower bounds? Or is it something that you're not really sure how you would approach or how you would do it? It's unfortunate. I think there's a bit of a lag again, unfortunately, this week. Maybe we've got sound this week, so maybe next week we'll get rid of a bit of a lag as well. So I'm hoping that you're all here and you're all happy to be here and you love maths. And okay, so good. So the replies are coming through. I can do some, but maybe need practice on hard questions. Haven't been through bounds yet. Okay, so we've got like a good mixture of people. Some who've never seen it, some people who feel quite comfortable with it but want a bit more practice. So, okay, so when it gets to like 3 decimal places, you find it more difficult. Okay, it's interesting. Okay, so we're just going to have a quick introduction to it because some people are completely new to the topic. So, and also it's a good refresher for those of you who feel more familiar. Everything is falling off my desk, which is wonderful. So, let me just switch to the whiteboard. Okay, can you all see this question? I'm going to start it instead of waiting, but tell me if you can't in the chat. I'll try and fix it. So a circle has a radius of 4.15 centimeters rounded to 3 significant figures. Calculate the upper and lower bounds for the area of the circle and give your answer to 3 significant figures in terms of pi. And I can see that you all can see it, which is fabulous. Okay, so answer in chat. Just because of the lag, I am going to have a go, but I'm going to keep looking back to chat to check that you're all with me. So for this question, we first of all want to do a little table of the values we already know and put an equation together for what we're trying to work out. So in this question, I'm just going to get the pen tool. We're being asked about the radius of a circle. Oh, sorry, about the area of a circle, and we're given the radius, I mean. So we first of all want to put together an equation that we know that links together area and radius. So type it all in chat. I'm going to give you like a few seconds. It does include pi. Maybe just write in chat pi for pi. And yeah, I'm just going to give you a few seconds to see if any of you know what the equation we want to be using here is. Okay, so the equation is the equation for the area of a circle. So we're going to do A for area. And for the area of a circle, it's pi r squared. And I can see them all coming through. You're all completely correct. Would this question be on calculator or non-calculator exam? For this particular question, like this specific example, it probably would be calculator. However, upper and lower bound questions could be on both. I would say get a calculator though, because I'm not trying to test your mental maths today. I just want you to feel comfortable with the method that you'd be using. Okay, so you're all completely correct. It's going to be pi r squared for our equation. And when I figured out that I want to do bounds for a question, I quite like to do a little table for the upper and lower bounds of all of the quantities that I already have, so that when I go to put it in the equation, I can just pick them out of my table. So for this example, we actually only have the radius that we don't know. So the table is quite a simple one. But I'm going to do over here, like so. Excuse the really wonky lines. Higher or foundation? I believe it can be on both, just at different levels of difficulty. It might depend on the syllabus. This should be useful for both. Okay, so here we know the radius, so I'm going to put the radius down here. And I'm in one part of the table, I'm going to have what the upper bound of my radius is. And then in the next column, I'm going to have what the lower bound of my radius is. So here we only have to worry about one value. So we've got the set radius of 4.15, and it's rounded to 3 significant figures. So we need to figure out what we need to add and take away to get our upper and lower bounds. And the upper and lower bounds, we're saying, given that we have already rounded our value of lots of decimal places to the value they've given us, what is the smallest value it could have been before we rounded it, and what is the highest value it could have been before we rounded it? And that's really what we mean by upper and lower bounds. So the two limits at each extreme that the true value could be. So for this one, we rounded it to 3 significant figures. So in terms of the decimal place we've rounded it to, we've rounded it to the nearest 0.01. It's under my head, isn't it? That just says nearest at the top. What we want to do for our bounds is we want to half the value that we've rounded it to the nearest of. So we take this 0.01. I see some people are having a go at the answers, which is great. Compare them in a second as well. So what we're going to do is, if we round it to the nearest 0.01, we're going to take that and we're going to halve it, which is going to give us 0.005. And this is what we are going to take away and add on. So it's not going to be 4 and 5, and it's also not going to be to the nearest 0.1 above and below either. Instead, for the upper bound, we're going to add this on, which is going to give us 4.155. And for the lower bound, so the smaller value it could take, is going to be 4.145. Reham, you're completely correct. Perfect. So this is where we start from. We've got what our upper and lower bounds are of our starting values. And now we can have a look at the equation and figure out which values we want to use to get the bound of the area. So here they're asking for both upper and lower bound. So I'm going to do it over here. And first of all, let's work out the upper bound. So area upper bound. Pi is just going to stay as pi because we want to write it in terms of pi. And then you want to ask, so if we're finding the upper bound of area, we want to find the biggest possible value of area. So do we want to use 4.155 or 4.145 in our equation for the radius? I'll let you think about that. So if we're finding the upper bound, we want to find the biggest possible value of area. And if we're finding the lower bound, we want to find the lowest possible value. We want to choose from our table the value of radius accordingly. Ella, where did you get the 0.01 from? So that 0.01 is from at the beginning of the question here. We're told we're rounding to 3 significant figures, which means we are rounding to the nearest one of these at the end. So 1, 2, 3. And I like to think of it, what am I rounding to the nearest to of? And then that's what I can halve. So that 0.01 is because for this value here, the third significant figure is on the 0.01 value. You've all completely correct. It will be 4.155 we use. Ella, let me know if that answers your question too, because I'm sure lots of other people have the same question. So yeah, so we want to just substitute that into our equation. Ooh, and let's use a proper pen, not the highlighter. So yeah, so we want to do 4.155 all squared for the upper bound. So I'll let you all put that in your calculator, let me know what you get. And then I'm gonna, while you're putting that in your calculator, I'm then gonna write out for the one below it, the beginning of this equation. And for the lower bound, we are wanting to use the lower value of r to get a smaller value of area in this equation. So we're gonna put in the 145 in here. Why do we divide by 2? So the reason we're dividing by 2 for this 0.01 is because anything halfway below that is going to round up to the 0.15. So for example here, for this example, if we go halfway of that interval below, we got our 4.145. And if you saw that in a question, you would know to round up. And the other way round for the 4.155, that's like the upper limit where we would start rounding up to the next value. So by halving it, you're finding the cutoff points for where you round up and down. And also, where do you get these equations from? So this is the equation. If you haven't done circle theorems yet, don't worry. But this equation is from your math syllabus when you start talking about circles. And the bounds questions often mix together equations you're supposed to know with upper and lower bounds. Like some of them you might have to come up with the equation yourself. So this is just the area of a circle. I believe a lot of the syllabuses give this in their formula booklet as well. And yeah, so we have some answers here I can see from Ciara. 54.2 for the upper bound. I believe you've actually put in pi as well, haven't you? So for this one here, they wanted it in terms of pi. I think the reason for that is so that we don't then have to worry about how we're rounding pi as well. Oh, where did I get the questions from? These I've based on old past paper questions, so that you still have other past paper questions you can go through, but this is a very standard question, just with the numbers changed around a little bit. Okay, so if you wanted to do this in terms of pi, I believe for the top one, what you should end up with is 17.3 pi. And the bottom one, it should be 17.2 pi. And then if you substitute in your pi into these equations, you'll get the values that you've mentioned down here. I'll just double check that I get the same as you when I put my pi in. So we've got our 17.3 by 3.14, which gets you your 54 one for the bottom, which is great. Depending on how many significant figures you'll have, it will change. And then for the top one, it will be 0.2. Which also gets this. So the number of significant figures you use for your pi will also change your value. But yeah, how many marks would this be? This one could be 2 or 3 marks. Rihan, don't worry about using pi. Just work out the value in front of pi. For this question, you want to look out for this in exam questions too. If it's saying in terms of pi, you just leave pi as that little symbol there. So that's like a bit of exam technique for you. So you don't, if you look out for the question, another way you could see this in an exam question is like if they use this word exact, which also means keep pi as that symbol pi instead of putting it in your calculator. Okay, but that's the first question. So that's just using one value here. Do your little table, upper and lower bounds for that value and figure out what you want to put in. Yeah, Reham, don't worry about finding the symbol. You're not going to need it for this. Okay, so let's go on to here. Okay, so a car travels 150 kilometers, correct to the nearest 5 kilometers. This takes the car 3 hours to the nearest hour. Calculate the maximum speed of the car that it could be traveling in kilometers per hour. Okay, so does anyone know the equation for speed here that we want to use? So you want an equation for speed. This probably crosses over a little bit with physics too, so you'll have learnt this same equation in physics. I'll give you a couple of seconds. Because of the delay, I'm just going to write it down and then compare it to what you're typing. So it's going to be, oh, perfect, Ciara, the timing is great. So distance over time, which you're all saying, great. Okay, so we now have, let me just move that over. We have an equation, and this time we have two different values in our equation. So we're just going to extend our table to include both distance and time. So we can do our little table down here. Again, we're going to divide our table into the upper bounds and the lower bound. We're going to write out the distance and time over here. So for the distance, we want to figure out what our upper bound is. And we've rounded it to the nearest 5 kilometers. So we'll have a go in chat. I will look at it in a second, at figuring out what the upper bound for distance is. But this one here, it's not rounded to the nearest kilometer. We've actually got a number in front of that. So whereas the one before, we were rounding to the nearest 0.01, this time the value we have is the 5. So we're going to take that 5 that we're rounding it to the nearest one of, and we divide that by 2 in this. Oh, I'll move that down. I keep forgetting my header's in the way. Let me just put this down here. Yeah, so we're going to take that 5 and we're going to divide it by 2 to get 2.5. So we always take the number that we're rounding to the nearest of and we halve that, and we take the halved value and take away and add it. Perfect, Jalay, you're completely correct. 2.5 is what we want to add and take away. So for distance, our upper bound is going to be adding this on. Oh, I'm very sorry. If I'm talking too fast, Benson, let me know if it's hard to understand. I'll try and slow down. But yeah, so for distance, we want to add the 2.5, which is going to give us 152.5. And for the lower bound, we want to take that 2.5 away. So it's going to be 147.5 for the lower bound. So you always want to watch out for questions like this where it's not just to the nearest kilometer. And this is why it's sometimes good to just remember this technique of asking yourself what the nearest thing is rounded to and just halve it. So for nearest decimal place, nearest significant figure, that will always be a 1, just to a different indice of 10, so 0.1 it could be. But yeah, in this case, we want to halve the 5. And then time down here, we are rounding this to the nearest hour. So 1 hour, we want to take that nearest 1 hour that we rounded it to and divide that by 2, which is going to be 0.5. So we want to add and take away 0.5 to the hours. These types of questions as well, a good first step is to check that we're in the correct units. For this one we are, because it's kilometers per hour, and our distance matches the distance, units in speed, and the time also is in hours. So for this one we don't have to worry. How did you get the answer for upper bound and lower bound? Oh, it went really low. So what we're doing for the upper and lower bounds, take the one nearest one we're rounding it to. So for that top one, the 5, halve it. And for the upper bound, I've just added it on. And for the lower one, we're taking it away. I see a lot of people asking like why we're halving it. One way of thinking of it is, here's our true value. I'll rub this out afterwards, but here is our true value. Oh, sorry, over here. And when we round it, we distort it. We either move it up or down. So what we're saying here is, from our rounded value, can we work backwards to find what the exact and the limits are for our true value in there? So that's why we're going up and down a half, because if we rounded here, halfway up from where we rounded it will be one part of the limit, and halfway from the other will be the lower limit. And then when we go past that limit, we then round up to the next number. So we're kind of, these halfway points are saying, how far up do I go before I would round up to 155? Okay, so our time one here, we want to add and take away a half. So for our upper bound, we want to add on a half to the 3, so 3.5. And for the lower bound, we want to take away a half, which will give us 2.5. Okay, good. I'm glad that makes sense. Oh, great. And then, yeah, now we want to go back to the question. Now we've got our little table over here. This table, once you're really comfortable figuring out those upper and lower bounds, shouldn't take you too long in an exam. But it's a good reference point. So we can now go back to our equation. We're trying to work out the maximum speed, which means that we're trying to find the upper bound of speed. So the biggest possible value that speed could take using our bounds over here. So question is, do we want to use the upper or lower bound for distance? And I'll let you think about that, put it in chat. So would you always divide by 2 for every question like this? Yes. Sometimes, like the one before, if it's saying to the nearest significant figure, you need to work out what it is you're dividing by 2. So in the last one, the third significant figure was the nearest 0.01. But once you've got that in your head of the nearest value, that's where you halve it. Okay, so where did 3.5 come from? 3.5 came from taking our 3 hours and adding on the half for that nearest 1 hour. Yep, upper bound for distance, perfect, because it's on top of the fraction. So to get the biggest possible value for speed, we want the biggest number on top of the fraction. So that's great. So we're going to use our upper bound for distance, which will be our 152.5. And then for time, do we want to use the upper or lower bound? So go back to the equation, figure out which one of these you want to use. Chelsea, do both. You could have all combinations, but it would take you more time. What we want to be doing here is going from the equation and saying, do I want to make distance bigger or smaller to get a bigger value of speed? Perfect, you're completely right, yeah. Lower bound for time, you're all completely correct, because it's on the bottom of the fraction, so we want to make that number small to get a big value for speed. Great, so that'll be over 2.5. And then if you put this in your calculator, you should get 61 kilometers per hour. So let me know that you're all happy with that. So yeah, and that's all we do. We still have a bit of time, so let's have a look through one more question that's over here. Actually, wait, I want to do the one after it, because this is a different style of question. So we're going to use this question. You might recognize this equation here. It's the equation for kinetic energy in physics. If a number is always at the top of the fraction, does that mean you always use the upper bound? It depends on if we're trying to find the upper or lower bound of the answer. So for the question before, to answer that, we use the upper bound here because we were finding the maximum speed. So we were trying to make the speed as big as possible. If we were trying to find the minimum speed, we'd be using the lower bound on top. Okay, so let's really quickly just have a look at this last question so that you can see another style of question here and notice the difference here. I'll let you all read through it, but we have an equation given to us. We're told the values of m and v in that equation to a certain number of decimal places. And then they're asking us to calculate e to a suitable number of significant figures. So for this one, they're not telling us find the upper bound, find the lower bound. Instead, we want to find both and then see which both of them are rounding to. So I'm going to work through this, put in chat all your answers. I am going to be looking back and forth. I'm just aware of time that you will probably want a full set of answers. So we go from E. Oh, actually, let's do it the same method we were using before. Let's first do our table. So put our m and our v in our table, find our upper bound, find our lower bound. So we've gone to the 2 decimal places, which means we've gone to the nearest, 0.01. So we're going to take, and we've done the same for both of them. So we go 0.01, divide it by 2, which will give us 0.005. And we're going to add this on for the upper bounds, take it away for the lower bounds. So for our m, it would be 3.555 for the upper bound, and for the lower bound, it would be 3.545, so taken away. For v, we're going to do the same thing. So the upper bound will be 1.655, and the lower bound will be 1.645. And we just want to plug these into our equation. So we're going to find what the upper bound for E is. First of all, this one, there's no division, no subtraction. So we just want to use the biggest values because that will give us the biggest value of E. So that will be a half. We're going to use the upper bound, so 3.555 times. And then we're also going to use the upper bound for velocity, so 1.655 squared, which should give you, and we're going to put a number of decimal places here. So that should give you, where is it? I'm going to put it over here. Okay, here we go. So 4.8686 16937, and we're going to do the same for the lower bound. Again, it'll be a half. This time we're going to use the lower bounds, so it will be 3.545 by 1.645 squared. Hope you can read that. My writing's not the best. And then this will go to 4.7964293125. And to figure out what a suitable number of significant figures is, you want to find the number that both of these round to. So regardless of if you're talking upper or lower bound, your answer will always round to this particular value. So for this one here, these both round to 5. They don't both round to 4.8 because the top one rounds up to 4.9. So a suitable number of significant figures for this example is actually just one significant figure. So we can say one significant figure as both round to 5. So E equals 5. Oh, I have a brother who's a big football fan, so I will take that as a huge compliment, Mikhail. So yeah, he's an Arsenal fan though, so probably not your favourite. Thank you all for being here, and it's so great to see some recognisable faces too. I did notice some of you were here last week as well. We're going to do some more maths next Monday at 5, so be there. If you have some free time on Friday, it'll be great to see you. There are also some other subjects on here as well. So there's some computer science on like artificial intelligence, which sounds like crazy interesting. And there's also some chemistry lessons, which are also really well done. So yeah, if you found this useful, also check those out because they'll also probably be really helpful for you. What's next week? I can check for you actually. I forget, but next week is... What is next week? Give me 1 second. Oh no, I've started a football debate. All the teams are good. So, okay, so go here. Yeah, next week we're going to be doing direct and inverse proportionality. So if that's something you think will be helpful, come and join. And yeah, have a lovely week. I hope this has set your week off to a good start. And I will see you then. Bye. Thank you all.